Hello and welcome to another one of these ADD videos. Today we're going to be looking at some examples of L'Hopital's rules and indeterminate forms. Um, real quick recap, the two main indeterminate forms that we're concerned with that allow us to do L'Hopital's rules are the infinity over infinity or the 0 over 0. Any of these other ones you're going to have to rewrite to put them into one of those two forms. Once it gets to that form, you can do L'Hopital's rule, which means take the derivative of the top and the bottom separately. Big red letters. Do not do quotient rule. Do the derivative of the top, and then a totally separate derivative, do the derivative of the bottom. Then you're going to reevaluate the limit, just like any other limit. If you rewrite it, you got to reevaluate, replug in. And if you get 0 over 0 or infinity over infinity, do L'Hopital's again. Okay, and you keep doing it until you no longer get one of those two indeterminate forms. Okay. Some scenarios you cannot do L'Hopital's rule. You just got to keep in mind that if you do L'Hopital's, it's just going to go over and over and over again. Usually it's a chain rule derivative, and you have a square root like this with a power of x greater than 1. Okay. So let's look at some basic examples, and let's watch how you would approach them. Example 1's right there. And what I would do is always plug in the infinite, and you don't need to actually calculate each one of these. Okay, look at the highest power, it's squared. Infinity squared is going to be infinity. Okay, and the denominator, 2 times infinity plus 1 is infinity. So you can see they're both going to infinity. One's going at a slightly different rate than the other. One's faster than the other, but we got to prove it somehow. We got to apply L'Hopital's rule, because that is one of the two scenarios in which we can. And here, when we take the derivative of the top, we get 2x plus 3. And then the bottom becomes 2. The next thing to do is to reevaluate this limit. And when I plug in infinity, I get infinity. Real quick recap. Infinity, sorry about that, over a number is equal to infinity. Same with 0 over a number is equal to 0. But when you flip them, you get the opposite one. So if it's over 0, it's infinity, and number over infinity is 0. Okay? So make sure you know those, have them memorized. Let's look at this next example. When I plug in a -3 on the top, I get what? 0, right? You should get 9 plus 6. Ooh, that should be a 2x right there. I'm sorry, people. I made these problems up, and apparently I rushed through them. I don't know what I was rushing for. I'm not even rushing. Oh my goodness, that was a horrible joke. I am so sorry I just put y'all through that. Let's fix this. 2x minus 15. A lot better. That does indeed give me 0 over 0. So when I derive the top, I get 2x minus 2 over the derivative of 1. Of the bottom is 1, sorry. And when I plug in, I get a -6 minus 2, which is a -8. Okay, so that would be your answer there. You could have also done it by factoring the numerator. The numerator, if you remember your factoring skills, is going to be x minus 5 times x plus 3. Over x plus 3. And you cancel these, reevaluate the limit. You get -3 minus 5 is -8. So either way, you get the same answer. It's just sometimes it's more beneficial to do the derivatives, okay? You're not always going to be able to factor and cancel like I just did. So on this one, if you look at what's happening here, sure enough, you do have infinity over infinity, because both the powers are to the 5th. Those of you that remember pre-cal, the asymptotes section for horizontal asymptotes, you should know the answer to this limit is going to be what? 1/2, right? But we have to prove it on tests. They can't just take our words for it. They don't know if you cheated or whatnot. So what you got to do is you could do L'Hopital's rule 5 times. Oh, you know what? I didn't put an L with a circle on this. Oh, I did. Okay. But not on this last one. So I did L'Hopital. So always make sure you do the infinity over infinity or 0 over 0 and then L'Hopitals. So on this one, if I were to do L'Hopitals, I'd have to do it 4 or 5 times before it started to get to something I could deal with. It's much easier when the powers are large like this and algebraic expressions on top and bottom. Factor out the largest common power. You're going to get 1 over 2x over x to the 5th. If you remember, had over factors, but how you figure out what's left. And then 1 over x to the 5th. All over, factor out an x to the 5th again. And when you do so, you can reduce. One of those goes away, and you're left with x to the 4th. One of those goes away with this one. Or actually, I'm sorry. You're only left with an x on the bottom because this was x to the 4th and this is x to the 5th. So you'd have an x to the 1st left. So if you cancel these two, reevaluate the problem that's left over, when you plug in that infinity everywhere in the denominator, all these terms that have x's in them are going to go to 0. Finite number over an infinite number is going to go to 0. And it, just like we said before, your final answer would be 1. And you have to show the work, unfortunately. So just in case you didn't get the concept of, if I have 1 over 10, look at what happens to the overall number as the denominator gets larger and larger. Overall number gets smaller and smaller. Eventually, it's going to go to 0. Okay. So I hope this is clarified. These are some of the basic limits at infinity problems with L'Hopitals that you might have to do. Make sure that you do recognize that it's easier to do algebra in some cases. So don't just do calculus. Don't forget your algebra skills. Okay. And make sure you check out the more advanced examples, because most likely your exam questions will be like those, not like these ones. These are pretty straightforward, okay? So more importantly than watching the example videos, make sure you practice, practice, and practice. The more you do, the less they can surprise you with. So I hope I've clarified things. Make sure you watch the example videos as I stated before, and I think I'm getting tired and I need a lunch break. So thank you, and have a nice day.